Welcome class. Thank you for joining me for 6-8, our final section on chapter 6. So for this first day of section 8, we are going to be talking about the graphs of square root functions. Now for square root functions, as you maybe hopefully picked up yesterday, the square root is the inverse of a square, of a parabola. Now by inverse, again, I mean it undoes it. So you already knew back in Expo, the square roots undo squares. But now in functional form, you know that that makes some inverses. Now, if you notice, parabolas do pass the vertical line test. So parabolas are functions. However, if you take the full inverse of it, its full inverse is actually not in a function, okay? So what we end up doing, the square root that you are going to know actually comes from what's called a restricted domain. So by restricted domain, that means we're only going to take half of the parabola, and that is what we flip. So when we think of the basic shape of a square root function, this is what we're talking about. We're talking about half of a parabola being inverted, okay? So again, to help you understand, to help you graph this later on, do know that this is the basic shape of a square root function, okay? Now, most of today is going to be focusing on families of radical functions. So what that means is we're talking about transformations. Now this is something you've done before. You've done a lot of transformations. So this really shouldn't be anything shocking or too new to you. However, something we're going to take some time to step through every type of transformation. So what we're going to do, we're going to start with the table of values for the basic square root function. So if you notice, every problem in your notes today has the basic table of a square root function. We're going to adjust the y values according to the stretch or reflection and plot those points. So we're going to actually plot that parent function. And then we're going to graph it by performing the shifts, so performing the translations. So again, that's the words to kind of describe what we're going to be doing. But what's more useful is just diving right in to our first example. So here we have square root of x minus 2. Now again, what I've done is I've given you the basic table right here. All right, so this is for the basic y equals square root of x. We start with our parent function. All right, so 0, 0, 1, 1, 4, 2, 9, 3. All right, so after we plot that basic parent function, it tells us to plot the translation. Now, that means you have to be aware, what does this translation do? Well, that minus 2 outside, remember that is a vertical translation. So what that means is every one of these points is going to be shifted down 2. And there is my square root function. Again, so pretty basic. As long as you know that first table of values, 0, 0, 1, 1, 4, 2, 9, 3. You could do 16, 4, but it wouldn't fit on the graph. As long as you can make that and perform the transformation. So once you plot those points, move it down 2, boom, you've got your graph already. All right. Horizontal translations. So remember, we also are able to move things along the x-axis, move things horizontally. So again, we're starting with our basic table of our y equals square root of x. So 0, 0, 1, 1, 4, 2, 9, 3. So there's all those basic points. And now what's happening? Well, now we have a shift with the x. So the x is shifting, okay? That's going to mean a horizontal translation. Now, remember, positive acts the opposite of what we'd expect. So Remember, that is not 4 to the right. That is 4 to the left. So I take each of my points. I'm going to move them 4 to the left. All right, and that means that is going to be my graph. So again, so far nothing too complicated. All we're doing, plotting that basic table and then shifting the points accordingly. All right, so now we're going to be combining transformations. Okay, so now in this instance, here's our basic table. Now, if you recall, so let's go back to the very first page because now if you notice, we have a stretch. And notice, what did it say to do with the stretch? It says adjust the y values according to the stretch and plot. So this time, because I have this stretch here, this time what I'm going to do is I'm going to make a table performing that stretch. So this is y equals square root of x. I'm going to plot y equals 3 square roots of x. So I'm just going to take that stretch and I'm going to make a new table. I'm going to multiply every y value by 3. Oh, I'm sorry. I wrote that wrong. That should be a 9. Okay, so you make a new table with the stretch. And that is what we're going to plot as our basic function. So 0, 0, 1, 3, 4, 2, 3, 4, 1, 2, 3, 4, 5, 6, then 9, 9. All right, so there's my graph with the stretch already included in that table. Now I go back and I perform my transformation or my translations. So that is telling me left 2, down 4. So I'm going to take every one of those points and I'm going to move it to the left 2 and down 4. So let's do it. Starting with that 0, 0 point. Left 2, down 4 will land me right there. For that 1, 3 point, left 2, down 4, left 2, down 4, left 2, down 4, and there we have the graph of our function. But again, the key thing is translations are doing exactly the same way. You're still just taking the points and moving them once they're already graphed. The stretch, however, you actually make a new table for. So let's do one last example. All right, so this is another situation. I see a stretch. So I'm going to take that graph, that basic y equals square root of x, and I'm going to make a new table with that stretch. And what that stretch does is it influences all of the y values. Okay, so I take every y value in that table and I multiply it by that negative 0.5. So let's see what we've got. We've got 0, 0. We have 1, negative 0.5. And again, for these, just do the best you can plotting them. 4, -1, 9, -1.5. All right, so check. I've done the first thing. All right. I've made a brand new table to include the stretch. Now I'm going to see what translations happen. Well, that's telling me to go to the right 3 and up 1 for every one of my points. So starting with the 0, 0 point, right 3, up 1. To my next point, right 3, up 1. My next point, right 3, up 1. My next point, well, now this one's going to go a little bit off, okay? So I'm just going to extend my table ever so slightly. Right 3, up 1. So I can still include it in my graph. And there we go. So again, just to wrap up, just give you a nice little summary of today, even though I've said it multiple times already. First things first, whenever there's a stretch, you're going to make a new table. You're going to plot that table, and then any translation, you're just going to manipulate the graph itself. Just move those points once they're already plotted. So please make sure that you have all this written down. If you have any questions, bring them back to class. We're ready to ask, and we will do our practice work together.